Good evening, students. Am I audible?
Yes, sir.
Okay, we shall get started. Yeah, I hope you're able to see my screen, right?
Yes, sir.
Yeah. So what the answer for the first one? You wrote the test yesterday only, no? I need some
Minus
fast.
7 and
Minus 7 into
10 to the minus 27 G.
10 power minus 27. That's right. So how did you get that?
U is equal to minus P cos theta.
Very good. So U is equal to minus PE cos theta. So what minus of, what is the value of P? 10 power minus 29. Is it in the standard unit coulomb meter? Yes. Into E is 1000. That is 10 power 3 into cos 45.
1 by
Cos
root
45 is going to be 1 by root 2. So from the concept of alternating current, we know that 1 by root 2 is 0.707. So it will be minus 0.707 into 10 power minus 26. So it will be minus 7.07 into 10 power minus 27 joule. Is it clear? Right. So shall I keep proceeding?
Yes, sir. Yes, sir.
Okay. So the electric flux through a closed surface enclosing charge Q is phi. If the surface area is doubled, you need not solve at all. Answer. If the surface area is doubled, what is going to be the flux?
Phi, sir.
It is going to be the same phi because flux is independent of area. And what does it depend on? It depends only on the total charge enclosed by the Gaussian surface. Right? Simple problem. Next. An electric dipole moment of P is placed, electric dipole of moment P is placed in uniform electric field. The torque is P vector cross E vector, potential is P vector dot E vector. The resultant force on the dipole is 0. What is the answer?
A, sir.
Sir, is it option? Sir.
Is it option B? So which one is right? B is right.
Yes,
Think
sir.
tell.
B.
But there is a small twist.
Sir, I think
A,
A is
sir.
right, sir.
A is right answer because what is missing in this? See, you did the first problem.
Minus sign.
Minus is missing, no? Minus P vector dot E vector. That negative sign has a significance. So option A is right. So this is where the ambiguity comes into picture. Right? Next.
Yes, sir.
Yeah. So a system has two charges Q A and QB and located at a distance, located at the points of this value. What is the total charge? So total charge obviously is going to be 0. Sum of the charges is 0. And what is the dipole moment? Dipole moment is how much? 2.5 into 10 power minus 7 into the distance between them is going to be 30 centimeters, which is 0.3 meter. Correct. So 2.5, so 25 into 3 is 75. So I need to 0.75 into 10 power minus 7 or 7.5 into 10 power minus 8 coulomb meter. This is the answer. So fourth one, C is the answer, correct. Okay. So did you understand why I wrote 0.3 and not 0.15? Because what should we take for the dipole moment? We need to take the distance between the charges. Right. So this is a problem which we discussed in the first class. The electric field required to keep a water drop of mass m just to remain suspended when charged with one electron. What is the answer, guys? So electron is there.
Option D.
So mg is equal to q into E or E into E. So capital E will be equal to mg divided by q. But what is q? It is E. Correct. This is the answer. Simple one, right? Is there anyone having confusion in this? Next. A charge Q is placed at the corner of a cube. The electric flux through all the 6 faces of the cube is. Answer.
B, sir.
How is it C?
Sir, it's placed at the corner, right?
Okay, it's placed at the corner.
Sir, so only 1/8 of the flux would pass through the cube, right?
Through all the 6 faces of the cube.
Yes, sir. For the 3 faces, it won't pass, and only for the 3 faces it will pass, and that is Q/8 epsilon naught, right?
See, if you take the cube to be in this way, okay, where is the charge placed? It is placed at the corner, right? So when it is placed at the corner, what is going to be the contribution it is going to place? So they're asking what is the electric flux through all the 6 phases. So through which 6 phases is it going to pass? So read the question, the electric flux through all the 6 phases of the cube. So if I take it here, will there be a flux taking place here or not? So how many phases actually get cut off?
Sir.
So 3 phases actually get cut off. So it is contributing only through the other 3 phases. Are you able to understand what I'm trying to say? So answer should actually be Q/3 epsilon naught, but here it is given Q by. Answer given here is wrong. They have given Q/6. So if we take this to be Q, okay. This is one side. Subhrit, tell me again, what is the answer?
Sir, but it like if we see the charge as a sphere, sir, then the corner occupies only 1/8 of the sphere, right? So
1/8 is the right answer actually.
Sir, so it should be Q/8 epsilon naught, sir.
That is right. That is right. Because I was.
Sir, in fact, we even discussed this problem in one of the.
I remember. But because
yes, sir.
I'm trying to cross verify with the solutions that I have. They gave it as Q/6. That is why I was thinking. Okay, Q/8 is actually right.
Yes, sir.
So in the solution sheet, no, once you get it, remember for this problem, option C is the right answer. It's given B, that is wrong. If possible, I'll change it there. Okay, next. So a parallel plate capacitor having area A and separated by distance D is filled by a copper plate of thickness B. The new capacity is?
Option D.
D. So what should you write? Epsilon, oh sorry, 1 minute. So what are the formula guys? Epsilon naught A divided by D minus T plus T/2. Right?
So T/K, right?
T/K, sorry. So T/K. So what is the value of kappa for a copper plate?
Infinity.
So this is lost. So epsilon naught A divided by D minus the thickness of the copper plate is B. So what is the option? D. Correct. So let me check if that is what they're given. 7D, correct. Next one. A capacitor of capacitance C1 is charged up to a potential V and then connected in parallel to an uncharged capacitor C2. The final potential difference across the capacitor will be. This I have explained. So what is the answer? Even without solving, you can say.
Option C.
Option C is the right answer. So how will you proceed? C1V1 plus C2V2 divided by C1 plus E2. Why did this come? Because of the charge redistribution, right? So C1V1 is going to be C1 into V plus C2V2 is going to be 0 divided by C1 plus C2. Right. So the angle between the electric lines of force and equipotential surface, theory question. They both are always perpendicular. So answer is 90. So dipole of relative permittivity epsilon r in the block, in the shape of a block is placed in uniform electric field E0. The intensity of the electric field inside the block is. So what will happen? There's something that happens in the case of polarization. The electric field inside will decrease by a factor of
the dielectric constant.
So what's the right answer?
Option A.
For example, had the question been given as instead of dielectric, they told a conductor of uniform conductor is placed in uniform electric field like this. Then what is going to be the electric field inside the conductor? What would be the answer?
0.
0.
0, because that's what the properties of conductor tells us. Yeah. So this one also I've explained in class. So 1 minute, 1 minute. So 9th one, 90 degrees, correct. 10th is A only, option A, correct.
The 9th one can show.
There are 90-degree angle between electric lines of force and
Okay.
equilibrium. The capacity of a pure capacitor is 1 farad. In DC circuit, its effective resistance will be
Infinite.
Infinite.
why?
Because
Why?
DC source capacitor does not allow current to pass through it in a DC source.
Capacitor does not allow direct current to pass through it. So infinite resistance. So the equivalent capacitance between the points A and B, what is the answer? So 4 and 3, they both are in parallel. So here it will be 7. 7 and 4 are in series. So what will happen? 7 into 4 by 7 plus 4. How much is that? 28 divided by 11. So on the top, you have 28 divided by 11. And at the bottom, what do you have? 8. This 6
1 by
and
4.
1 by 4 or 4?
4, sir.
It is 4.
Oh, sorry, 4. 4, yes.
It is 4 because 8 and 8 are in series. So 28 by 11 and 1 by 4 are in parallel again. So 28 by 11, am I right? 28 by 11, is it coming?
Yes, sir.
Yes, sir.
Yes, sir. 28 by 11 plus 4. So 28 plus 44 divided by 11. So how much is the answer? 72 divided by 11. Did they say approximately?
6.0 Newton.
Is it exactly 6? 12 by
No,
72?
sir. It's not exact.
It's not exactly, no? So 12th one. Actually, they got 2 here. I think there is a mistake in the question, but 6 is approximate. 6 is the right answer. But they should have mentioned it approximately. Okay. Yeah. Next, this one.
Sir, 0, sir.
Why is it 0? Batteries are of equal potential. Right, answer will be 0. But 13th option is given as B.
Sir, if we solve using Kirchhoff laws, means we get answer as 2 amperes.
2,
Yeah.
sir.
It's right only. Actually, you will not get it. So when you redraw the circuit, how is it going to look like? This is 12. This is 12. And they are connected across the 5 ohm resistor. So this 12 and 2, this is 12 and 2. So these two cells, how are they connected?
Parallel, sir.
So when they are connected in parallel, right, what is going to be their equivalent EMF? You know this? E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2. Am I right? So what is E1? 12 by R1 is 2. So 12 by 2. How much is it going to be? It is going to be 12 only. So what is E equivalent by R equivalent of both? 2 and 2 connected in parallel, 1. So E equivalent will be 12. E1 by R1 plus E2 by R2. Both are 12 only, no? 12 by 2. So 2 by 2 is supposed to 12. 6 plus 6 is supposed to be 12. So 12 and 5. Did you get exactly 2?
Sir, I got minus 2 amperes. Sir.
It means you have taken the direction wrong, but it's still fine. it should work actually. So the equivalent EMF should be 12. Correct. So the equivalent EMF is 12. Listen, guys. Did you understand this formula? Did you guys understand this? So this is the formula for cells connected in parallel. Okay. Please make a note of this if you don't know.
Sir,
Ah.
sir, why didn't the polarity are connected in opposite ways? So why didn't it get cancelled out?
Because they are in series only, no? You see, this is supplying some current. This is supplying some current. At the junction, what is happening? They both are getting added and the current is going here as 2I. Puriyada?
Yes, sir.
They would have got cancelled had it been like this.
Yes, sir. Got it.
Got it? So they didn't get connected on the same side. So did you all understand this formula, guys? I need a confirmation. E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2. Am I clear?
Yes, sir.
So R equivalent is 1 ohm. Right? Now, if you redraw the circuit, this will become a resistor of 6 ohm. Why did I make it 6? Because this 5, 1 ohm from the internal resistance will get added. So it will become 6 ohm. Am I right? So V is equal to IR. So 12 is equal to 6 into I. What will be the value of I? It will be 2 ampere. The answer will be 2 ampere. Guys, did you understand or not? This is an important point I wanted to discuss. Is it clear? Is there any step that is not clear?
Sir,
Tell me.
sir, in assignment, I think there was a similar problem, but I did not understand the solution. Could you explain it?
See, thing is, when two cells are connected in parallel, do you know this formula or not? You know this?
Yes, sir.
You know it, no? Okay. So what I did here is, I found the equivalent EMF by using this. I got it as 12 volt. Okay. Now, let me do it in the other page. So the equivalent EMF is 12 volt. And what is the equivalent resistance? The internal resistance of the cell is 1 ohm. Now, this battery is connected across the 5 ohm resistor, external resistor. Now, what I want to do is, I want to apply Ohm's law.
Understood,
So
sir.
now you got it?
Yes, sir. Yes, sir.
Yeah, yeah. So is everyone else clear? So answer 2 ampere is right answer. 0 is wrong. 2 ampere is
Sir, I have a
right.
doubt, sir.
Yeah, please tell me.
If we use Kirchhoff law, will we get the same answer?
You will. You should. You should get the
Yes,
same.
sir.
Answer. If you want me to do and show, I'll do it. If somebody wants, I'll do and show. Why to be with
Yes.
doubt? Did you use Kirchhoff's law? But in your 1 enna, so in get 12, in get 12. This is there, right? Here, you should remember that you're connecting a small resistor of 2 ohm. Correct? Yeah, because it has some internal resistance. But for this kind of a problem, I would not suggest to use it. Seriya. But I'll solve and show. If this current is I, can I say this current is also I because they're of the same nature? 12 volt, 2 ohm,
Yes, sir.
12 volt, 2. Right? Appa inga current evlo irukum? It will be 2I. Right? So how many unknowns do I have? How many unknowns do I have?
Only one, sir.
One unknown, how many loops do I need?
One and
That's it. So remember in Kirchhoff's law, the number of unknowns is equal to the number of loops that you need. Suppose I take the loop A, B, E, F, A. When I go from A to B, I don't have any device, so leave it. When I go from B to E, am I going from higher to lower potential or lower to higher? I'm walking in the direction of current. So in the direction of current, negative. So minus IR. That is why minus 2I into 5. Chariya. So what about E to F? Nothing again. And from F to A, when I'm going from F to A, I am going in the direction of lower to higher potential. Correct? Guys, yes or no? Higher to
Yes, sir.
lower potential.
Yes, sir.
Up a minus 2 higher. And across the battery, I'm going from lower to higher. Plus 12. Correct? Should be equal to 0. So 12 will be equal to 2I.
Oh, sir.
Tell me.
Sir, it should be plus 2, I know, sir.
Minus, because in the direction of current is negative. Current always flows from higher to lower. That
Okay,
is
sir.
what I
Got
do.
it, sir.
Yeah, got it. So 12 ohm, 12 volt is equal to 12I. So I will be equal to 1 ampere. So if you write the answer as 1 ampere, it is wrong. Why? Because 1 ampere is the current supplied by each battery. What did they ask? What is the current flowing through the 5 ohm resistor? Up answer another 2I. That will be 2 ampere. Kaushik, you got it?
Yes, sir. Clear, sir.
Got it. So whether you apply Ohm's law or Kirchhoff's law, it will give you the same answer. It should. Seriya? Okay. Mobility definition.
Option
Will
D,
be
sir.
discussed. D. Last one.
Yes, sir. D for that.
Yes. So the magnitude of drift velocity divided by electric field. So VD vector divided by E is what is going to be the mobility. It is represented by mu. Right. Next. Kirchhoff's first and second law of electrical circuits are the consequences of conservation of option. Conservation of electric charge and energy respectively. 15B is the right answer. The internal resistance of a cell of EMF 4 volt and internal resistance of 0.1 ohm. It is connected to an external resistor of 3.9 ohm. The voltage across the cell will be. So what is the value? I will be equal to I will be E divided by small r plus capital R. So E 4 divided by small r plus capital R is 4. So I is 1 ampere. So voltage across the cell is getting discharged. So discharge R, what will be the terminal potential difference? V will be equal to E minus IR. So E is how much? 4 minus I is 1 into R is 0.1. So 4 minus 0.1, how much is it? 3.9 volt. That will be the answer. Clear, guys? Is there
Sir.
anyone who's not? Yeah, please tell me.
Sir, if we are charging, it will be E plus IR
E plus
in
IR.
case of charging. Yes, okay.
E plus IR. I didn't draw the diagram.
Yes.
I hope everyone is clear, right? Yeah. Can I have confirmation from everyone? Everyone is clear?
Yes, sir. Yes, sir.
Yes,
sir.
So here, our is saying is discharging.
Engada? See, எப்பவுமே சார்ஜிங்ல என்னன்னா the question will have another battery of a greater EMF.
Okay.
இப்போ இதுல பார்த்தனா ஒரு சோர்ஸ் தான இருக்கு.
Yes, sir.
So you cannot charge that source with the help of a resistor. Resistor is a passive element. So now it is discharging now.
Okay, sir.
So in the arrangement of resistance as shown in the figure, the potential difference between the points B and D will be 0. Okay, B and D are 0. When what will be the unknown resistance? So what does it form, guys?
Wheatstone bridge.
Does it form? Is it a balanced Wheatstone bridge?
So the question, it should form, sir.
Is it so? The
Yes,
potential difference between B and D is 0, means B and D are at the same potential.
Sir, if they are at the same potential, no current will flow. So they are balanced.
But they are not connected, no. So it becomes an open circuit, okay. If it becomes an open circuit, are you trying to say that Yeah, it forms a balanced Wheatstone bridge, correct. So this should be 16, this should be 4. This is X, this is half. Am I right, guys?
Option D, sir. Yes, sir.
So 16 by 4 should be equal to X divided by half. So 4, X will be 2. This one, no? Let me check if that is answer. Yeah, 2, correct.
Yes, sir.
So the reason being balanced Wheatstone bridge. So what was the answer for the previous one? I didn't check. So 3.9 volt, correct.
Sir,
Yeah, Sulra.
sir, so if it's not a balanced Wheatstone bridge, we need to solve using Kirchhoff.
Kirchhoff's use பண்ணாதீங்கடா. See, I'll tell you one thing. Forget Kirchhoff's law. When you have a question with only one cell, if you have, first of all, they didn't give you the potential difference or the EMF of this cell. You can't solve it. Okay. ஒருவேளை கொடுத்திருந்தா, okay, Nitish, are you with me?
Yes, sir.
ஒருவேளை had they given it, don't think of Kirchhoff's law when you have only one cell. This is a thumb rule I would like to stress upon. You start thinking of Kirchhoff's law only when you have a complicated network.
Okay, sir.
For example, in this problem also, it is actually not a complicated network. I can still solve it using the cells in parallel combination. So I didn't go with Kirchhoff's law. Okay. Same is the case here. So what you do is find the equivalent resistance,
Yes, sir.
right? And they would have asked current or something. They should have given you the potential of the battery because you cannot have two unknowns and one equation. You cannot solve it. Sure, yeah?
Okay. Okay.
Yeah. So when the electric current through a conducting wire along, so when there is an electric current through a conducting wire along its length, then the electric field must exist. Obviously, in
Inside the wire but parallel.
inside the wire, parallel or normal?
Normal.
Okay. I'll confuse you. You should be confident.
So it will be parallel.
Parallel, correct. AM parallel because if you take a conductor inside, yeah.
Sir, but inside, like a conductor is usually, a wire is usually metal, right? So inside metal, the electric field would be 0. Wouldn't it?
I expected this question, but Subhajit, you have to listen to one point. Electric current abdina flow of charges. Listen to this. Electrostatics of conductor says under static condition, the electric field inside a conductor is 0, not under the dynamic condition.
Understood, sir.
Got it? So here you have positive charge, negative charge. There is an electric field existing. If there is no electric field, who's exerting the force on the electrons? If that is the case, you will not get drift velocity also, right? So it's a part of the derivation of drift velocity concept, guys. I hope everybody is clear with this.
Yes, sir.
So what is electric charge? Simple question. Charge is an intrinsic property which is responsible for exerting a force on other particles, right?
Sir, will you be sending this in learning room?
I'm sorry. Can you come again? The solution sheet.
Yes, sir.
I'll send it. Don't worry.
Okay, sir.
By
Thank
tonight
you.
it will be uploaded. After this class, you will get it. Don't worry.
Okay,
So electric charge. Yeah. Yes. So electric charge definition another. It is an intrinsic property, right? Due to which materials will be able to exert force on the neighboring charges or neighboring particles, right? So is it a scalar or a vector? Obviously, scalar. And what is the SI unit of it? It's going to be Coulomb, right? Next, an electron moves a distance of 6 centimeters. So S is equal to 6 centimeter. It is accelerated from rest. U is equal to 0 by an electric field of strength 2 into 10 power 4 Newton per Coulomb. Calculate the time of travel. S is equal to ut plus half at square. So I'm writing only half at square because U is 0. So half into what is the value of electric field? Is it not Q into E divided by M into T square, So this is S. So S is 6 into 10 power minus 2 is equal to half into charge is 1.6 into 10 power minus 19 into 2 into 10 power 4 divided by the mass of the electron is 9.1 into 10 power minus 31 multiplied with T square. So how much are you going to get? This will cancel this 3 times. This is going to cancel this. No cancellations. So it's going to be 3 only here. So it will be 0.8. So T square is equal to 3 into 9.1 divided by 0.8 into 10 power minus 15. Okay. So what you can do is you can do an approximated value. So T will be equal to square root of 3 into square root of 9.1. Can I approximate it to 3 divided by 0.8? What I'll do is I'll write it as 8 into 10 power minus 16. So 0.8 into 10 power minus 15 is the same as 8 into 10 power minus 16. What is square root of 8? It is 2 root 2 into square root of 10 power minus 16 is 10 power minus 8. Am I clear? Yeah. So all
Sir,
these are
approximation can be done, right?
Yeah, you can do see 9.1 because you'll not be mostly given like logbook is there, means you can solve it. If it is not there, go with approximation. Still, it's going to be fine.
Okay.
10 power minus 16. T square is 10 power minus 16, correct, Dana? We'll go to numerator as 10 power. 9. Oh, this I forgot actually. That is why I was wondering, because answer is coming in terms of 10 power 8, which is very, very long time. So into 10 power minus 31 regular. So this you can take it to the numerator and then do it.
Sir, in numerator plus 31 will come.
It will go to the other side as multiplication, you know.
Oh, okay, got it.
10 power minus 31. So square root of what we can do is, can I write it as 30 into 10 power minus 32? So the square root of 30 into 10 power 32, now it will be 10 power 16. Sorry, minus 16. So this will go up. So 3 into root 30 divided by 2 root 2 into 10 power minus 8. This I think you can handle it. Right. So root 30 means 5 point something. Okay, answer will come out to be 0.585 into 10 power minus 8 seconds. Right. So I hope the concept is clear.
Sir, we can expect these kinds of root calculations.
Not much.
Okay.
Will not give. See, I gave it to make sure that if you ask me, I'm only concerned till this point.
Okay, sir.
Sketch the equipotential surface for uniform electric field. So uniform electric field, what are the equipotential surfaces? You will have the plane surfaces like this. So these are the equipotential surface. I hope everybody knows this, right? There are 3 other surfaces which you need to practice. Look at your textbook and then practice. Equipotential surface in your NCERT is only 1 page. At the bottom, you will have diagrams. Make a note of all those points. Right. So 4 capacitors of value 6 microfarad and 3 are of 6 microfarad and 1 2 microfarad are connected to a 6-volt battery as shown in the figure. Determine the equivalent capacitance of the network. So 6, 6, and 6, all the 3 are connected in series. So what will be the equivalent?
Two, sir.
It will be 2. Because it is 6 by 3, no? It's going to be 2 microfarad. 2 and 2 are connected in parallel. What will be the answer?
4.
Right. Sorry, you're right. 4. Correct. So it will be 4. C equivalent will be 4 microfarad. Correct. What is the charge on each capacitor? Can you find it? Q is equal to CV. So on this 2 microfarad capacitor, what is going to be the value of Q? 2 into 10 power minus 6 into V is 6. It will be 12 into 10 power minus 6 coulomb. Is it not going to be the same across this also?
Yes, sir.
Yes. Why is it so? Because whenever capacitors are connected in series, first you need to find the equivalent capacitance and then find the charge. So it is going to be 12 microcoulomb. So 12 microcoulomb on 2 and 12 microcoulomb on each of 6. That's the answer. So correct. That's the
Sir?
value. Tell me.
Sir, we found out equivalent capacitance and we got equivalent voltage. We can find Q, right?
That's what we found. Q is equal to CV. இங்க பார்த்தா equivalent capacitance is 2 தானடா. அதனால தான் I multiplied the 2 with 6. I didn't multiply each 6 with 6 பாரு. I didn't do that. புரியுதா நான் சொல்றது? What is the confusion you have?
Sir, just a minute. Fine, sir, got it.
Got it? So an electric dipole of length 2 centimeter is placed along the place with its axis, making an angle of theta is equal to 60 degree with a uniform electric field of value 10 power 5 Newton per coulomb. If it experiences a torque of 8 root 3 Newton meter, find the magnitude of the charge on it. So how to do it? Torque is equal to P sin theta. Right? P euro. Q into 2 into 10 power 5 into 10 power minus 2, because remember L is in terms of centimeter. 10 power minus 2 into sine 60 is 8 root 3. Okay, sine 60 is how much? Root 3 by 2, root 3 and root 3 will get cancelled. 2 and 2 are lost. So what will you have? Q will be equal to 8 into 10 power minus 3 coulomb. So this is the magnitude of the charge on the dipole. So 8 into 10 power minus 3 coulomb, correct. Potential energy of the dipole, U is equal to minus P vector dot E vector minus P evolada. Q, you got it, no? So 8 into 10 power minus 3 into 2 into 10 power minus 2 into E is how much? 10 power 5 into cos 60 is half. So 2 and 2 is gone. So 8 into minus 8 into 10 power minus 8 then. So 10 power minus 5 and 10 power 5 will get cancelled. Minus 8 joule should be the answer. Correct.
Sir,
Tell me that.
sir, can you go to the before?
Previous one.
Sir, we found out the effective charge, right?
Effective charge கிடையாது அது. It is the charge on each. So you are saying since you found the equivalent capacitance and then found, you are saying effective charge. Is that what you want to perceive?
Sir, my idea is like we have the effective capacitance and effective voltage. We'll find the effective charge and we'll find the charge on 2 microfarad capacitor and
2
subtract it
microfarad equivalent.
in parallel.
So you want to calculate that also you can do. You can do that.
Okay, sir.
If you do it in that way, you will get the effective capacitance is 4 microfarad. Effective voltage on the 6. Effective charge எவ்வளவு இருக்கும்? 24 microfarad. Out of 24, this 2 microfarad capacitor has taken 12 microfarad. So what is remaining?
12, sir. Yes, sir.
Sorry, microcoulomb. So resistance of a coil used in platinum resistance thermometer at 0 degrees Celsius is 3. So R initial is 3. R final one the 3.75. Its resistance at an unknown temperature is measured to be 3.15 ohm. Calculate the unknown temperature. How much is the answer, guys? So how will you do it? Ri is equal to Rf into 1 plus alpha into delta T. Right? So R1, R2, R3, T1, T2, T3. So T1 is 0 degrees Celsius, 100 degrees Celsius. How much? This is the capital T. So R1 is 3, R2 is 3.75, and R3 is 3.15. So it should definitely be less than 100 degrees Celsius. How did I say it should be less than 100 degree? Because the resistance has dropped, right? So if I take these two into consideration, I write alpha with this. Alpha will be equal to 3.75 minus 3 divided by 3 into 100. 0.75 divided by 3 into 100. So how much is it? 0.25 by 100 or 0.25 into 10 power minus 2. Okay, adhe mari alpha will be equal to, if I take these two values, 3.15 minus 3 divided by 3 into t. This is equal to 0.25 into 10 power minus 2. One unknown, one equation. Can you solve this? So 0.5 divided by t is equal to 0.25 into 10 power minus 25. So what will be the value of t? Ten power minus 2. So 100 divided by 5. This goes 5 times. So 100 divided by 5 is 20. So that's the answer, guys. Did you understand what I did?
Yes, sir.
So how many of you got this 20?
Yes, sir. Thanks, sir.
I got so.
Got it? Good. So answer is 20 degrees Celsius. See, actually in this problem, the external resistor was missing, but I thought you can draw and do it. So 3 cells of EMF E, 2E and 5E with internal resistance R, 2R and 3R and variable resistance capital R as shown in the figure. Find the expression for the current. So how to find the value of current? I will be equal to, so how are these cells connected? They are connected in
Series.
series. So what will be the answer? 9E divided by, what is going to be the equivalent resistance? 3R plus 2R plus R.
Isn't it 80?
80, sorry. So 80 divided by 6R plus capital R. Correct.
Yes, sir.
Yes, sir.
Yes, sir.
So 80 divided by 6. Again, for this, don't look at the solutions. There is a mistake. Okay. 80 divided by 6R plus capital R. They are asking for variation of current with capital R. So this R is a variable resistor. That's what they have mentioned. See, you will be given marks for this question. Don't worry. It's a mistake from our side. So I and R, if you observe, I is inversely proportional to R. So as you keep changing this value in the denominator, the whole value will decrease. So this is going to be the graph.
Oh, sir.
Tell me.
Sir, but isn't this the graph for if it was inversely proportional to R square?
No need. It's inversely proportional to R also. It's the same because xy is equal to c. Y is inversely proportional to x. The graph is like this.
Sir, but like, why wouldn't it be a straight line?
It will be
Decrease.
only a straight line. What is the equation? X and y should be directly
Y is
proportional.
equal to mx plus c.
They should be directly proportional, no? Y and x. Here, if you observe, they're asking the variation of current. So current is y. So y is equal to a divided by b plus x. So this b plus x is also some variable capital X. Can I say it? Though b is a constant, as the value of x is changing, it will be a variable value. So how is y proportional to? Y is inversely proportional to that capital X. So as the
Understood,
value of
sir.
x is increasing, y should decrease exponential. Okay, this actually there is a formula for rectangular hyperbola. So this is how the graph will look. And what is going to be the coordinate of this point?
80 upon 6 small r.
So 4e by 6r or 4e by 3r. That is 80 by 6r or 4e by 3r. So I'll be back. Okay, now some. So this one is clear, right? 3-point charges plus q are kept at the vertex of an equilateral triangle of side L. Determine magnitude and sign of a charge to be kept at the centroid so that the charges at the vertices remain in equilibrium. So what is the answer? So if you read the question carefully, they don't want the charge at the centroid to be at equilibrium. They want the charges at the vertices to be at equilibrium.
Sir,
So what should the
is it? Sir, I don't remember properly, but it's something minus q and root 3 will come. So
correct? Minus q by root 3. So how to proceed? Tell me the.
Yes, sir.
You remember the procedure? No?
Yes, sir.
So Q and Q are placed here. This is capital Q. Suppose I'm saying the charge at vertex A is at equilibrium, right? Then what are all the forces acting on it?
Sir, like if the point is O, then OA, OB is.
So this Q will experience force due to whom?
Three of the charges.
So force due to B on A will be in this direction. So can I say if AB is this? What about this thing? It is F AC. Right. FAB and FAC will be equal to how much in terms of magnitude? KQ square divided by A square. No doubt in that. They both are of equal magnitude. Let me call this as F. So how much is this angle?
Sir, L square, right?
Okay, whatever it is.
So the angle will be 60, sir.
60 because vertically opposite. So this will also be 60. And when two forces are acting at a particular angle, how will the resultant be? It will be an angular bisector. Am I right? So answer will be root of F square plus 2 times F square cos 60. Right? So what will be the answer? Root of or root 3F. Correct, Adam? Guys, am I clear or not?
Yes, sir.
So root 3F is a force in upward direction. To nullify this force, there should be a force acting in the opposite direction. Means the positive charge Q should experience an attractive force towards this capital Q. So root 3F should be equal to KQ into capital Q divided by how much is the distance between these 2 points?
1
How
by
much is
root
it?
3L. 1 by root 3L.
So A by or L by root 3, correct?
Yes, sir.
So it is going to be L by root 3. So root 3 into F is KQ square divided by L square is equal to KQ into capital Q divided by L divided by root 3. 1L is L square by 3 upper. I'm sorry, here I wrote potential. It should be L square by 3. So L square by 3. L square and L square are lost. K, 1Q is lost. So which implies capital Q will
The
be
root 3
equal.
will also be lost.
Which one?
Root 3.
Root 3Q divided by 3. So which will be Q by root 3. But that Q by root 3 should be a negative value. A negative. Only then it can experience an attractive force. So answer is minus small q divided by root 3. That's the answer. Correct. Is there anyone who didn't understand any of the steps? I actually did it in a minimalistic way. Is there anything that is not clear?
Sir, attractive forces we should always put negative, sir.
You should put negative, but since I put the direction, right?
Oh,
when you write
okay.
it in system, no, you should say, since root 3f is acting in the vertically upward direction, the force at the charge at point A should be in the opposite direction. So Q should be a negative value. But what I did here is I equated only the magnitudes. That's why I found the magnitude and then put a negative sign.
Okay, sir.
Got it? Yeah. Next. Define the term electric dipole moment. Product of magnitude of either of the charges and the distance of separation between them. So derive an expression for the total work done in rotating a dipole through an angle theta in a uniform electric field. This is a theory question, right? So you can just go through the video to have a look at it. I don't want to waste time on this. Derive an expression for the electric field due to a dipole at equatorial point. This also you guys can derive it, right?
Yes, sir.
And again, go through the video if you have any, because I've given a detailed explanation. So derive an expression for drift velocity of electrons in a conductor. There is also a theory question. Go through the video. So what will be the value of Vd? Minus E into capital E divided by M into tau, where tau stands for the relaxation time. Next. Use Kirchhoff's laws to obtain the conditions for the balanced Wheatstone bridge. Theory. So what are the condition base? So first of all, how to draw a Wheatstone bridge? There should be 4 resistors which are arranged in the shape of a quadrilateral. P, Q, R. Okay, I'll take this as R and this as S. A galvanometer is going to be connected here. And there is going to be a cell that is connected here, or a battery, whatever you call it. So what do you mean by a balanced Wheatstone bridge? Current through the galvanometer is supposed to be 0. So when the current through the galvanometer is taken to be 0, and you write down the equations using Kirchhoff's rules, right? What will you get? P divided by R will be equal to Q divided by S, or P by Q will be equal to R by S. So P divided by Q will be equal to R divided by S. Right. Again, for this, if you want a detailed explanation, please go through the video. There is a separate video itself. So 31. So dielectric slab is a substance which does not allow the flow of charges through it, but permits them to exert electrostatic force on one another. When a dielectric slab is placed between the plates, the field E0 polarizes the dielectric. The induced charges minus QP on the upper surface and plus QP on the lower surface are found on the dielectric. These induced charges set up an electric field inside the dielectric in the opposite direction of E0. Correct. So having all these points in mind, in a parallel plate capacitor, the capacitance increases from 4 microfarad to 80 microfarad on introducing a dielectric medium between the plates. What is the dielectric constant? So C is equal to kappa times C naught. 80 is equal to kappa is kappa only. C naught is 4. So what will be the value? Answer is 20. So this is a problem. I think we solved it in the class also. So C is 20. No, sorry, kappa is 20. Next. A parallel plate capacitor with air between the plates has 1 minute. With air between the plates has a capacitance of 8 picofarad. The separation between the plates is now reduced to half, and the space between the plates is filled with a medium of dielectric constant 5. Calculate the capacitance of the capacitor in the second case. Answer.
80.
So how do you do this?
So it become modified into 10 into the capacitance.
So C naught is how much? And steps, how will you write it in the exam? That I'm concerned about it more. So C naught will be epsilon naught A divided by D. Correct? C dash n kappa times epsilon naught A divided by D by 2. It will be 2 kappa times epsilon naught A divided by D. But what is epsilon naught A divided by D? That is C naught. So it will be 2 kappa times C naught. Appa C dash n 2 into kappa is 5 into C naught is 8. Answer will be 80 picofarad. I hope you wrote the same steps in the exam. Okay, let's see. So this is 80 picofarad. A dielectric introduced between the plates of a parallel plate condenser decreases. So what does a dielectric do? Decreases the electric field between the plates, increases the capacity of the conductor, increases the charge stored in the condenser, increases the capacity of the conductor. Actually, option B and B. Sorry?
Option A, right?
Sir, is it B?
Actually, A and B both are right. B and D, though they are the same, A and B both are right, because electric field becomes E naught divided by kappa. It is decreasing the electric field. Secondly, it increases the capacity of the both are right. So here, whichever option among A, B, and D, whichever you have picked, you will get the mark. Okay, so marks to be awarded for this. Generally, a dielectric, see, the objective of introducing a dielectric itself is to increase the capacity of the condenser. See, suppose, let's say the same question comes, forget about D. Let's say they have told decreases the capacity of conductor. Let's say they have given option like this. If suppose the same question comes in boards, choose this answer. Choose B. Okay, because if somebody asks why is a dielectric introduced, the main objective is to increase the property of that condenser. Condenser is a capacitor. To increase the property of that condenser, what is the important property of it? Its capacity. So B is more closer answer, though A is also right. Here it is slightly ambiguous, but you will get marks. But if it comes in board, please go with option B.
Sir?
Tell me.
Sir, here C will be proportional to the ratio of Q by V, right? Not.
But here it is not Q by V. No, it is about electric field. Huh?
Oh, okay.
Yeah,
Sir?
actually, wait. No, option B is more precise. 1 minute. Introduce between the plates of the capacitor. Tell me. Yeah, I'm sorry, guys. I'm sorry. Option B is right. Or B or D, whichever is you have taken, is right. Because when they say it is decreasing the electric field between the plates. See, for example, if a dielectric is introduced only to this extent, okay, how can I say that the electric field between the plates has decreased? It is still E naught only. Only inside the dielectric, it will become E naught by K. So option B is right answer. I'm sorry about it. Option B is right. It has nothing to do with the electric field between the plates. Only the electric field inside the dielectric will decrease. Yeah, somebody called me. Any doubt?
No, sir, I got it, sir.
Got it? So, guys, I repeated. option B or D is the right answer. So parallel plate capacitor of capacitance 1 picofarad. So capacitance is 1 picofarad. Has a separation between the plates as D. When the distance of separation becomes 2D and the wax of dielectric constant X is inserted in the capacitance, capacitance becomes 2 picofarad. So 2 is equal to so C dash is equal to epsilon naught A divided by D dash, which is 2D kappa times. So it becomes kappa by 2 into epsilon naught A divided by D, which is kappa by 2 into C naught. This is C dash. So C dash is 2. So 2 is equal to kappa, that is X divided by 2 into 1. Up X order 4. This is the answer. Four is the right answer. X is 4. So parallel plate capacitor having been filled with is the same, no? Epsilon naught A divided by D minus B, option C. This is a balanced Wheatstone bridge. How to solve this? So I'm not reading the theory and all. So there are 4 resistors, R1, R2, R3, R4. The null point condition is, that is the balance condition. What will happen?
D, sir. R2 by R1.
R2 by R1 will be equal to R3, D, R3 by
Yes.
R4.
Ah,
Yes,
R2
sir.
by R1. A letta?
Yes, sir.
A
A,
is the
sir.
right answer. A is the right answer. Because where is R2 is, and let me redraw it 1 minute. R2 is R1. This is R3, this is R4. So R1 by R2 should be R3 by R4. That's the answer. A is the right answer. So the Wheatstone bridge is used for the precise measurement of answer. So why do we use Wheatstone bridge?
To measure
To find
unknown.
the unknown resistance. Other which one will be concentrate, high resistance or low resistance?
Lows.
Low is the right answer. So what happens if the galvanometer and cell are interchanged? This is another important question. So
No
in the
deflection.
in the balanced condition, if you exchange the galvanometer and cell, it is still going to have no deflection. So there is actually a meter bridge question.
Sir,
Hmm.
could you show the third question?
Third, engagement.
Oh, okay, sir.
Third, what is the question?
Just
Why
a
are the
minute.
connections made between resistors and meter with or Wheatstone bridge with of
Actually, meter
thick
bridge
copper
is not
strips?
there. You should have actually not got that question. Answer is, see, since you have practical circular, so they might ask you, why are they connected like this? So it is to minimize the resistance. Just make a note of that point. If it comes in Viva, it will be helpful for you for practicals.
Okay, sir.
Okay, minimize the resistance. Adhe Mari, for this one, you will get marks. Don't worry. Again, there's a Wheatstone bridge. Wheatstone bridge actually thing is X by L1 will be equal to Y divided by 100 minus L1. And this is how you need to do it. But I'll give you marks for this.
Sir, but what is the answer for this question?
I'll tell you. So X by L1 எவ்வளவு கொடுத்திருக்கான் 39.5.
Yes, sir.
So 39.5 is equal to Y வந்து எவ்வளவு 12.5 divided by how much is it? 61.5.
60.5, sir.
60.5. So 60.5 now it is 125 divided by 605. Everything is a multiple of 5. So answer இங்க வந்திருக்கிறது 8.2. This answer. Not sure if you got the same.
Yes, sir. Got it.
Got it, sir.
8.2. Sir.
Sir, for the third one,
The third question it got missed.
sir, it should be.
Minimize the resistance.
Yes, sir. Okay.
33. State Gauss law in electrostatics. The surface integral of E vector dot ds vector is equal to 1 by epsilon naught times the charge enclosed by the Gaussian surface. So use this law to derive an expression for the electric field due to an infinitely long straight wire of linear charge density lambda. Lambda coulomb per meter. Hence, answer another. Electric field is equal to lambda divided by epsilon naught r. So what Gaussian surface will use? Cylinder and all those things you know, no? Next. An electric dipole consists of charges 2 into 10 power minus 8. So here it is 2 into 10 power minus 8. Here also 2 into 10 power minus 8, which is separated by distance of 2 millimeter. It is placed near a long line charge. So when they use the word long, it means infinite length of charge density 4 into 10 power minus 4 coulomb per meter. This is the lambda. Calculate the force acting on the dipole. So how do I calculate the force? So force is equal to Q into E. Am I right?
Sir, is
So
it
what-
0?
Why would it be 0?
Sir, but distance of dipole is negligible compared to the distance from the
But still,
dipole.
that small value also you need to calculate. That value is ignored when you calculate the electric field due to a dipole at some other point. But here, this E that you're going to write is going to be the electric field generated by the state current carrying conductor. So here the electric field is going to be in this direction. So negative charge will experience a force in this direction and positive charge will experience a force in this direction. Here it will be QE1 and here it will be QE2. So the net force will be Q into E1 minus E2. Why I wrote E1 minus E2 is I took left hand side to be negative. Sorry, left hand side to be positive. Tell me among E1 and E2, which one will be more? E1 will be more because the distance is less. It's inversely proportional to R, no? So Q is how much? 2 into 10 power minus 8 into, what is the value of E1? Lambda divided by 2 pi epsilon naught into R1 is 2 into 10 power minus 2 minus lambda divided by 2 pi epsilon naught into R2 is 2 into 10 power minus 2 plus 2 into 10 power minus 3 or point. So it will be 2.2 into 10 power minus 2. Right? I hope you understood this. So you have to substitute all the values. So 1 by 2 pi epsilon naught is how much actually? See, 1 by 4 pi epsilon naught is 9 into 10 power 9. So 2 by 4 pi epsilon naught will be 18 into 10 power 9. Right? So substituting all those values and you calculate, you will get the answer as 0.66 Newton, and that 0.66 Newton is acting in the leftward direction.
Sir,
Hmm.
sir, here one suggestion. Sir, for the electric field, if you multiply and divide by 2, it will be easy for calculation, right?
Where?
In the electric field due to line charge.
Yeah.
No, sir, in the electric field due to infinitely long.
Yeah. It's the same thing. That's what I did here. That's not 2 by 4 pi epsilon naught and I did it separately. That's it. It's the same thing. We both are speaking the same language. Different steps. I hope you understood, right? See, this kind of a question you can expect. I saw it in 2018 paper. You can expect it. Okay. So 33. I remember 34 another. This is an NCERT question only. Two tiny spheres. So tiny means particles. Spheres carrying charges 1.5 microcoulomb and 2.5 microcoulomb are located 30 centimeter apart. Find the potential and electric field at the midpoint of the line joining the two charges. So what is going to be the potential? So V is equal to 1 by 4 pi epsilon naught into 1.5 into 10 power minus 6 divided by 15 into 10 power minus 2 plus 2.5 into 10 power minus 6 divided by 15 into 10 power minus 2. So 1 by 4 pi epsilon naught is 9 into 10 power 9 divided by 15 into 10 power minus 2 into 2.5 plus 4.5 is 1.5 is 4. So 4 into 10 power minus 6. So this will go 3 times and this will go 5 times. So 3 into 4, 12 divided by 5 into 10 power 9 minus 6 is 3, 3, 5. So 10 power 5. There's going to be 2.4. So 2.4 into 10 power 5 volt. Clear? So 2.4 into 10 power 5 volt is going to be the potential, not the potential difference. Similarly, what about the electric field, guys? What about the electric field? 1 by 4 pi epsilon naught into 15 into 10 power minus 2 the whole square. If I take it out, it will be 2.5 into 10 power minus 6 minus 1.5 into 10 power minus 6. So it will be 1. So 9 into 10 power 9 into 10 power minus 6 divided by 15 into 10 power minus 4. So this will go 3 times, 5 times, and this will go 5 times. So 10 power 3, so 10 power 7 divided by 25. So I can write as 100 into 10 power 5 by 25, which is 4 into 10 power 5 volt per meter or Newton per coulomb. Clear? So electric field is 4 into 10 power 5 volt per meter. Now what about the potential at a point 10 centimeter from its midpoint in a plane normal to the line and passing through the midpoint? In somewhere on the equatorial point is what they're asking. So anybody with the answer?
Sir,
So if you draw the
is it 2 into 10 power?
2 into 10 power 5, correct. So this is P. For me to calculate the potential at this point, 1, 2. At P, total potential will be V1 plus V2. So 1 by 4 pi epsilon naught into 1.5 into 10 power minus 6 divided by R. So how much is this distance, guys? So midpoint, this is 15, this is 10. 10 only, no? 10. So how much will this be? Root of 225 plus 100. So it should be root 325. So what is root 325? $18 point something. So this
Sir,
one,
or else 5 root 13, sir. Root 13 is 3.6.
18.02.
That's what 324 is. Square root of 324 is 18. It will be somewhere near that. So 10 power minus 6 divided by the same R. So 18.02. I'll approximate it to 18. So here also it will be 18. So this is 9 into 10 power 9 divided by 18 into 10 power minus 2. And what will you have? 4 into 10 power minus 6. So this will go 2 times, this will go 2 times. So 2 into 10 power 3, so 10 power 5 volt. Correct. So that is the potential difference. Sorry, potential. How to calculate the electric field? So this electric field is slightly a complicated one. So 1.5 into 10 power minus 6, 2.5 into 10 power minus 6. This is 18, this is 15, this is 10. So electric field due to this will be in this direction. Here it will be in the opposite direction. So E2, if you know the angle between them, right?
Sir, but we don't need to know the angle.
How will you find it then? You
Sir,
need the
cos
result.
theta and so
Yeah,
cos
E1
theta
square
is
plus
enough.
E2 square. Yeah, cos theta, that's what. E1 square plus E2 square plus 2 times E1, E2 cos theta. So if this is theta, this is also going to be theta. Right, but how do we know the angles between them? So if this is theta, 1 minute, I'll do it in another way. Okay, I'll take this to be theta, this to be theta. So how much will this be? 180 minus 2 theta. So this will also be 180 minus 2 theta. Okay. So root of, what will you have? Then it will be root of E1 square plus E2 square plus 2 times E1, E2 cos 2 theta with a minus sign, because cos of 180 minus theta is minus cos theta. So you'll have minus this thing. What is the value of E1? E1 is 9 into 10 power 9 into 1.5 into 10 power minus 6 divided by 18 square, 18 into 18. And E2 is 9 into 10 power 9 into 2.5 into 10 power minus 6 divided by 18 into 18. Okay. So it goes 2 times. So 1.5 into 10 power 3 divided by 36. 9 into 10 power 9. Here also it goes 2 times. So you'll have 2.5 into 10 power 3 divided by 18. 18, the 36. Okay. So don't worry, you'll not get this stuff calculations and all. So if you know what is cos theta is going to be 15 by 18, which is going to be 5 by 6. Then you can find what is cos 2 theta. That is 1 minus 2 cos square theta minus 1. So 2 into cos square theta is going to be 25 divided by 36 minus 1. So 50 minus 36 divided by 36 is 14 by 36 or 7 by 18. Take this value and substitute it here. E1 square plus E2 square minus 2 times E1 into E2 into cos 2 theta is 7 by 18. By substituting all those values, you will get the answer as approximately 6.56 into 10 power 5 volt per meter. See, if you have written these steps, you will get marks irrespective of whatever your final answer is. Okay. If you have written these steps, you will get marks. I'm not concerned about the final answer. I'm only concerned about the effort. And in boards, you'll not get this stuff and all. Okay. Next. So derive an expression for drift velocity. This is a repeated question. Right. Similarly, a wire whose cross-sectional area is increasing linearly from its one end to another. Okay. Is connected across a battery of V volts. Which of the following remains constant in the wire? Answer.
Currents.
Sir, for the before question, deduce Ohm's law.
That is also derivation, right? So what you will do is you will have Vd is equal to E into capital E divided by M into tau, no. So you will write this as E into capital E. So E by M into, instead of capital V, you will write it as V by L.
Okay.
Purida. Adi Mari, you know that I is equal to NEA VD. Upper VD and our N I divided by NE into A. So that will be substitute I divided by NE into A is equal to E divided by M into V by L, which implies V will be equal to
Sir, BD will be E tau by M.
Did I miss that tau?
No, sir, you couldn't do it. Oh.
Okay, divided by A into tau multiplied with I. So it's the Ohm's law.
Okay.
This is R, so you'll get V is equal to IR.
Sir, for the second one, is it current density?
1 minute, I'm checking.
Sir. Sir, in this question, if the cross-sectional area is increasing, then the length need not change, right?
Length will not change. So there is a wire like this whose cross-sectional area is increasing linearly. Here you have connected a potential source. So when you've connected the potential source, what are all the factors that are going to be constant? So if you see drift velocity, is it dependent on the length or the cross-sectional area? No. So drift velocity will be a constant. What about current density? So they're asking for which of the following quantities will remain constant in the wire? This is the last question, right? So what is the answer? Only thing that is going to change is current density.
Sir, I have.
Sir, current will also change, right?
Yes, sir.
Right.
Because
Sir,
resistance.
V equals to IR. In that formula itself, A is changing.
So V is equal to IR and R will be equal to rho into L divided by A.
So current will increase as the area of cross section increases, right?
Just thinking. So I is equal to V1, can I write it as NEA into VD into this I can write it as rho L divided by A. Electric current should change.
Sir, can electric field come, sir?
Electric field won't change because electric field depends on the battery that you have connected. Since it's a constant voltage, battery is going to have the same this value, same electric field.
The drift velocity is I by NE, A is changing also.
Not like that. You don't take it in that way. No? So E into capital E divided by M. So E capital E M and tau is what is going to change.
Okay.
So I'm just thinking about the electric current. Electric current, how do I take? V is equal to IR. Logically speaking, R is not a constant. Actually, the electric current also should change. That's right. So let me check what they have given.
Sir, current density J will be equal to NEVD, right? So E is constant and
It's ambiguous. 1 minute. Let me do it again. So here I think they have given it completely different. See, let's think of the logic. Okay. So if I take this to be the potential source, when the cross-sectional area is changing, what will happen to the resistance? It will change. Since the material is constant, resistivity alone will be constant. Okay. So what about the drift velocity? Vd is equal to small e into capital E divided by m into tau. Let's discuss about each parameter. Let's think from the logical perspective. Okay. So when this constant electric field is going to exist inside, right? Small e is constant, capital E is constant, m is a constant. Then what about tau? The relaxation time, what is going to happen? Is it going to be the same? So what is relaxation time? It is a time existing between two successive collisions.
Sir, so will it increase?
It should change actually.
Yes,
It will
because
change.
with increase in area, the collisions between the protons would.
It should change. So VD should change because of the relaxation time. That is one point. Second is I is equal to NEA VD into rho into L divided by A.
Sir, V is equal to any AVD, sir.
So which one?
V is equal to any AVD.
V is equal to NEA VD. So I will be equal to NEA into VD. Now tell me, area is changing, right? When area is changing, what is happening to the drift velocity? These two parameters, are they not changing together? Listen to this carefully. Are they not changing together in such a way that the product of A and VD should be a constant?
Yes, sir.
So
Sir,
what
so
will
you're
happen?
like if VD increases, A decreases, so the product.
It should happen in such a way that the product of both should be a constant. So what will happen to I?
It should remain constant.
But what about current density? I divided by A is equal to NE into VD. This is J. Now VD is changing. So what will happen? Current density should change. But what about the electric field? That can be a constant. So what are the two parameters that are going to change? Drift velocity, and based on drift velocity, it is the current density that is going to change. Current is going to be a constant.
Sir, why is drift velocity changing?
Because of the relaxation time. The more broader it becomes, what will happen to the relaxation time?
Sir, I have a doubt.
Tell me.
Sir, in the narrow part of the wire, there'll be less electrons, and in the broader part, there'll be more electrons. So relaxation time remains the same.
It's not the same, no, because they have more time to move. And they have
Sir,
more
but
space.
in the same time, there are more electrons, right?
No, it will not be the same. The speed will change. You remember the Bernoulli's theorem? You remember equation of continuity?
Yes, sir.
A1 V1 will be equal to A2 V2. It's the same logic, no? When the area is less, the speed will be more.
Sir, but in that, the volume is same now.
Here also the same thing, no?
Sir,
It's
but
the
here
same
the
logic.
volume of
Something is-
electrons is not same, right?
It's not the volume, right? It's the number density that is going to be the same. Here you don't speak about volume at all, no? Here it is a number density that is going to be same. So when you want the constant current to be taken out, right? When you want the current to be constant, according to the expression that we are getting, if that has to be constant, the drift velocity should change according to the cross-sectional area. So
Sir,
that is what
I'm trying to say, if there is more area, then at the same time there are more electrons, right? So, like ultimately, the time, like in the narrow part, there are less electrons, and in the broader part, there are more electrons.
No, that's not the case. When it is crowded, see, what is relaxation time? Tell me. There's a time taken between.
Sir, two successive collisions.
So what do you mean by successive collision? Once the particles are colliding, right, they're getting separated. Again, the next time they're undergoing a collision, right? That is what is called a successive collision. So do you mean to say that when the particles are closer by, they have the same relaxation time as compared to the point where they are broadly spread?
Sir, but what he's trying to say is that the electrons are not broadly spread because there will be more number of electrons in that area.
Exactly, sir.
Which area? In the
In the
point.
wider, no, not that side, so the other side, where the area of cross section is more.
But you have more time, they have more space across them, right?
Sir, how so?
Sir,
The
but there are
number of
more electrons
will
also, no?
increase, right?
How will they be? How will they be? Think about it.
The metal is not like, the density of the metal still remains the same, right? You're not
Density of the
expanding.
metal is the nature of the metal. I'm talking about the number density here. The number of electrons per unit volume, is it going to be the constant? That is what my question is. You think about the number density here. Don't think about see, when you talk about the density of the material, you're talking about the resistivity of the material. My question is,
Sir, so where is number density equal, sir? It is not going to be same, no, because volume of
it is
the
not going to be
broader
like
part
the
is
same.
more.
It is going to be like this. For a cylindrical conductor, it is going to be the same.
Sir, yes, sir, exactly. For cylindrical, it's same, but for this thing, it's not same, no.
It should not be the same. That's what I'm saying. So that is the reason why the relaxation time also will be changing. Because it depends. See, when they are closer, right? It is like kinetic theory of gases only. What happens to the gases, gas particles, when they are closely packed?
Sir, but
The
here
relaxation-
the metal is not expanding due to any thermal or any other force, right? The
It need
metal is
not be,
as
right?
such.
It not be, because once it is getting a collision taking place, right? The particles are going to get separated.
Sir, but the metal is okay. So the atoms will be packed in the metal uniformly throughout, right? So the
Yes.
number of electrons will increase as the surface area increases, right?
But that's what I'm saying. Now think about it. When something is pushing, okay, you're pushing someone in a less crowded place. Are you not having more space to move? Is what I'm saying. I'm saying,
Sir,
are you
but the
not
crowd is
more-
same in the both places, right?
They're saying that the population is same.
Yes, sir.
Sir,
In both.
population compared to the area, like not only population, like population by area.
Sir, that is like in the smaller area, na, if there is like, for example, a number of electrons, but then if you go in the larger area, na, the number density will be the same, no, sir. So there will be a lot of electrons compared to the smaller electron.
Okay, but how many? How are you visualizing relaxation time? Why are you talking about more number of electrons? I'm taking only 2 electrons into consideration. I am saying, what is the time existing between those 2 electrons? And my question is very simple. What is the time existing between those 2 electrons for successive collisions to take place? Think about it. That is what I'm trying to answer. I'm not talking about population here. When you give more space, are they going to come back and collide faster or slower? Is what my question is. That's what my question is. Think about it.
Sir, but for one last time, the amount of material present will not change, right? So let's say if in the lower surface area I have 10 electrons, in the higher surface area I'll have 20 electrons, right? Like,
okay.
So the number of electrons in that particular given area is constant relative to the area. So if I'm trying to collide both the electrons, the relaxation time will still remain the same.
Sir, if like it's like Boyle's law, no, sir. V is inversely proportional to pressure.
But here pressure is not the concept, right?
No, sir, I'm just comparing. Yeah, it is not, but it's somewhat like that, right?
Let me give a benefit of doubt for what you're asking also. Let me think about this. Okay. As far as I am concerned, my theory is right, but I'll think about your theory also. You're saying that more space also, you're going to have same number of electrons. Then what about the relaxation time? it should be the same as what you're saying.
Yes, sir. It will have more
If
number
that
of
is the-
electrons.
If that is the case, then none of the parameters should change according to this question, because if drift velocity is not going to change, then the current density also should not change, right? Am I right?
Sir, but still the current will increase, right?
Sir, Abdina,
Yes, sir.
then if drift velocity did not change, then the area is only changing, no, sir. So the current will increase.
V is equal to IR if you apply. You're saying V is constant, I is there. This you are taking rho into L divided by A. So this one you want to change, take it to the other side. You're saying I is equal to A into V divided by rho into L. Is that what you are trying to say? So I will,
Yes,
this is your
sir.
theory. This is your
Yes.
theory, right?
Yes, sir.
Okay. So the answer to that lies in the question of drift velocity changing or not.
Sir, I have a doubt.
Hmm.
Electric field remains same, right? Sir, then why can't we say like J will be equal to sigma E?
You can say that.
But again, sigma depends on area of cross section,
Because the
right?
conductivity, you know.
Yes, sir.
Conductivity depends only on the nature of the material.
Okay, right, sir.
Yeah. So conductivity is the reciprocal of resistivity. Resistivity is constant. So there are multiple theories that are coming out. Okay, let's have a discussion on this. Okay. Let me also refer. So according to me, the relaxation time should change, right? Anyways, I'll refer that and come back. Let me think of a better theory.
Okay.
Sir,
Okay.
conductivity won't change, right?
It will not.
Yes, sir.
The J is equal to sigma E itself came by rearranging these equations. We derived that Ohm's law. இதுதான் resistivity. Sorry, resistance. அப்ப R is equal to M by N E square tau into L divided by A இருக்குல்ல, இதுதான் resistivity. அதோட reciprocal தான் conductivity.
Yes, sir. If this didn't change, then VD should, that theory also should be true. Then that means VD shouldn't be changing.
That's what, see, we are trying to give different theories to it. We are trying to give different theories to it. That's what I'm saying. So when I write the basic expression of small e into capital E by M into tau, okay. First of all, I'm just thinking if we are right in using this equation at all. Okay, I'll think about this now. I'll think about this. Okay, I'll give you an explanation. Don't worry. So as of now, for this also, I'll give you marks. Okay. But let us discuss it. So here it is given. Current remains constant throughout the length of the wire. The electric field also remains constant, is equal to E by L. Okay. Current density does not changes as the area changes continuously, and hence drift speed also changes. Electric field is constant, no doubt in that. It's only about the drift velocity that we need to talk about. So let's see, because there are multiple formulae, right? Here the theory is completely different. I'll have a look and come back. Don't worry. Okay. So is that all? This is the last question, no?
Yes,
Shall we wind up?
Yes, sir.
Okay. So we'll see. Okay.
Thank you, sir.
Solra.
Sir, I have a doubt in another problem from